So in this video we're going to talk about quadratics going in between standard form and vertex form, how to get from one to the other. We talked about this a little bit, but I want to be a little more clear about this. Sometimes you want your equation in standard form, all like multiply it out with like your a, b, and c. Sometimes you want it in vertex form, like maybe you want to know the vertex or you want to know what transformations are happening. So there's different times when you want your equation in these different forms, so you need to know how to go from one to the other. We're going to start by going vertex to standard because that one's easier. All you have to do is just expand it out. Do x plus whatever squared, distribute whatever might be in front, add the thing on the end, and you're done. So we'll just go through a few examples of this. Remember, order of operations does apply, so parentheses happens first, meaning x minus 3 is kind of stuck together. Then exponents. I cannot just square both of those. That's not the full answer. To square this, squaring something means multiply it by itself. So I'll do x minus 3 times another x minus 3. Keep the negative 2 in front, keep the plus 5 on the end. All right, now I need to distribute. I could actually do negative 2 times that first if I wanted to, but I'm going to go ahead and do x times x, which is x squared, x times negative 3, which is negative 3x. Negative 3 times x is another negative 3x. And negative 3 times negative 3 is positive 9. So all of this turned into this expression here, which simplifies to x squared. Combine these and you get negative 6x plus 9. You still have the negative 2 in front, and that negative 2 was being multiplied by everything in the parentheses originally, so the negative 2 still needs to be multiplied by everything in this set of parentheses here. The plus 5 is just on the end. Multiplication comes before addition, so I'm going to go ahead and multiply the negative 2 by distributing it out. So that's negative 2x squared, positive 12x, and then negative 18. And now that I've dealt with the distributing, I can ditch the parentheses, and now I'll just add the 5. These are like terms, so negative 18 plus 5 is negative 13, and I am done. So I'm going to say y equals, and so this is the standard form of this equation. This is vertex, this is standard. You just multiply it out until you're done. If you were to graph both of these, they would be literally the same equation. If you were to put in values for x, you would get out the same thing for y using either equation. They're the same, just different forms. Go ahead and pause the video and try this one on your own. So hopefully you've tried it. I'm going to go through it now. There's no number on the end here, so I don't have to worry about that. But some people get confused and try to multiply the 1/2 right away. And you don't want to do that because, again, order of operations. You have to square it first. Exponents comes before multiplication. So to square it, again, remember that means multiply it by itself. So I've got x plus 4 times x plus 4, which is x squared plus 4x plus 4x. 4 times 4 is 16. And I'm going to go ahead and simplify this. So 4 plus 4 is 8x. Don't forget, originally all of this was being multiplied by 1/2, so I still need to multiply everything by 1/2. So just distribute the 1/2. A half of x squared is just 1/2 x squared. 1/2 times 8 is 4. Half of 8 is 4. And a half of 16 is 8. And that's my final answer. Everything's all multiplied out. As far as it can go, that would be a, b, and c. This is standard form. It came from vertex form. I did want to point out, notice a couple things. These numbers don't always match up with this number, like you'll see that on that first one as well. These numbers don't always match up with these numbers, but whatever's in front matches the leading coefficient. The leading coefficients match in this case. And they do here as well. 1/2, 1/2. That actually always happens. The leading coefficient always stays the same. And so you'll notice in the formulas, and these are on your formula sheet if you forget them, you'll notice whatever's in front, we call that A in both formulas. I'm not sure why it's different fonts, but we call that A. That's on purpose. These are always the same, regardless of whether it's in standard form or vertex form. Okay, so we just did vertex to standard, you just multiply it out. Now let's work on going the other way, so from standard to vertex. There are two pretty good ways to do this. One way is, like we talked about a few lessons ago, you can do completing the square. That kind of takes a little while, so there's an easier method that I personally like better to get from standard form to vertex, and the answer is just find the vertex. If you could take this and find the vertex, put it in for HK, leave the A value the same, you're good to go. So that's what we're going to do. In vertex form, it's very easy to see what the vertex is. Remember, this number right here is H, which is the X coordinate of your vertex. This number right here is K, which is the Y coordinate of your vertex. You do have to be careful because it's always minus H. So if you had +3 for the vertex, it would be -3 in the equation, although K is just always as it is. For this one, the vertex would actually be at 0, -15. That's because there is no H. Like there's nothing in there with the X. Like there's no plus or minus anything with the X. And so the H part is just 0. The Y, or the K, is -15, so the vertex would be 0, -15. Okay, so there's a few different ways you could find the vertex. If you have an equation that's in standard form rather than vertex form, it's a little harder to find the vertex, but it's not that crazy. So you have two options. One is you can always graph it. You can use Desmos, your calculator, you can graph it by hand. You could always just graph it, see where the vertex is. In this case, it's at 0, -1, and then use that to find the vertex. Another option is there is a formula to calculate the vertex. That's pretty handy that you should know. So let me show you that. It looks like this. Again, here's standard form. You've got A, which is in front of the x squared, B, which is whatever's in front of the x, and C by itself. That's the same as we have been doing. The vertex, to find the vertex, you're going to do -b over 2a. That is your h, the x coordinate of the vertex. So negative whatever this number is over 2 times whatever this number is. That gives you the x coordinate of your vertex, which we call h. To find the y value for that x, you just plug it into the formula and see what it spits out. That might not make a whole lot of sense, so let me show you what I mean by that. Also, this is not on your formula sheet. This is one that you're going to need to memorize. So maybe make up a little song or something to memorize it. I remember this because it's kind of like the quadratic formula. You know, in the quadratic formula, it's -b plus or minus all this stuff all over 2a. It's kind of just this. It's like the very beginning and the very end of the quadratic formula. So that helps me remember it. Also, I did want to distinguish this formula from one we've seen in the past, which is b over 2 squared. This one is to help you complete the square. So this is what you add in when you're completing the square. This is the x coordinate of your vertex. So they're actually very different, but they seem pretty similar. So just thought I'd distinguish those. Okay, let me show you how this works. So for example, imagine I have this quadratic equation and I want to find the vertex. So I could graph it and just see where the vertex is. Or I could do -b over 2a. this is my A right here, the 1/2. B is whatever's in front of the X, which in this case is a 1, and then the 5 is C, but I don't need that. So I'm going to do negative B, so negative 1 all over 2 times A, which is a 1/2. Two times a 1/2 is actually just 1. So this is negative 1 over 1. And negative 1 divided by 1 is negative 1. This is my H, the x coordinate of my vertex. So I'm going to have a vertex, and I know that the first part is negative 1. Now I need to find the y value that goes with it, which we call k. It's really easy to do that. That's what your equation does. An equation literally spits out the output for various inputs. So if I want to find out what the output for this is, I'll just put it into my equation and see what it spits out. So to find k, I'm just going to put negative 1 into my equation. 1/2 times negative 1 squared plus negative 1 plus 5. So I just replace those x's with negative 1, the h value. And now you can put all that in your calculator if you want, or do it by hand. Negative 1 squared is positive 1, and 1 times a 1/2 is 1/2. And negative 1 plus 5 is plus 4, so it would be 4.5 here. And if you want to check with your calculator, you can. 0.5 times negative 1 squared. Yeah. So that is my k value, which is the y coordinate of your vertex. So again, to find h, the x coordinate of your vertex, you just use the little formula, and then plug in whatever you get to your equation to find k, the y value. All right, so in this case, the vertex is negative 1, 4.5. Let's try another one real quick. Again, if I want to find the vertex, I'll just use that formula. So negative b over 2a, that's my h. Be careful here because a is 3 and b is negative 5. So when you do negative b, you've got to do negative 5. And then for a, we'll put in 3. And so negative 5 is actually just 5 over 6. So 5/6 is the x coordinate. To find the y coordinate, you just plug it in. We call that k. And so I'm going to do 3 times 5/6 squared minus 5 times 5/6 plus 1. So just replace those x's with 5/6. I'm definitely just going to put all that in my calculator. 3 times 5/6 squared. Oops. 3 times 5/6 squared minus 5 times 5/6 plus 1. And all of this is negative 1.083 repeating. I'm going to make that a fraction, which is negative 13/12. So there is the vertex for this one. All right, so let's use that to actually take an equation in standard form and write it in vertex form. It's not going to require any more work than what we just did. So if you want to write this equation in vertex form, remember vertex form looks like this. All I need to know is hk, which is the vertex, and your a value, which is the leading coefficient. Remember, the a value always stays the same. If it's 2 there, it's going to be 2 here. So I've already got that part down. It's the same. Now I just need to find the vertex, fill that in, and we are done. So do what we just did to find the vertex. For the h value, it's negative b over 2a. So there's b, there's a. So negative 4 over 2a, so 2 times 2. Negative 4 is positive 4, 2 times 2 is 4, so 4 over 4 is 1. That's my h. So that's the x coordinate of the vertex. And then to find k, remember you just plug it in. So take the 1 and put it in for x. So 2 times 1 squared minus 4 times 1 plus 5, which would be 2 minus 4 plus 5, which would be 3. Okay, so that's my vertex. This is h, this is k. I'm just going to put those into the formula. It's x minus h, so it's going to be x minus 1 squared, with the 2 in front, and then plus k, so plus 3 in the end. That is my equation in vertex form rather than in standard form. Again, you could complete the square, so you could do completing the square with this instead to turn it into vertex form, but I kind of like this way better. Let's try another one. Maybe pause and try this one on your own, and then unpause and I'll go over it here. Once again, I want it to be in vertex form, so something that looks like this. Actually, I should probably call it f of x since it's called f of x. And again, this is on your formula sheet, so feel free to use that. Okay. Once again, the a value is just going to stay whatever the leading coefficient was originally. It's actually just a 1 right here, so it's going to be a 1 for me as well. I don't really need to write that, but I'll write it for now just so you know that that's what that is. That's a 1, and so we're putting it here. Now, again, I just need to find hk, the vertex. So to find h, again, do negative b over 2a, which in this case is negative 12 over 2 times 1, which is negative 6. Then to find k, take negative 6, put it into your equation. So negative 6 squared plus 12 times negative 6 plus 32. I'm going to put all that in my calculator. And I got negative 4. So this is h, this is k. Just put them into the formula. I'm going to do x minus h. So I'm going to do x minus negative 6, which is going to turn into a plus 6. And then plus k would be plus negative 4. So let's write this all a bit nicer. X minus negative 6 is really just x plus 6. And adding a negative is really just subtracting. And I don't need to multiply by 1 because that's kind of redundant. I don't need to write that. So this is my final answer. This is vertex form. Just remember, whatever you have here is always going to be the opposite of whatever your h coordinate is. If this is negative 6, you're going to have plus 6 here. The k stays as it is, but whatever's inside the parentheses is opposite. Let's try one more. Nope, 2 more. Let's write this one in vertex form. Okay, so this one seems to be missing some things, but that's okay. Once again, I'm going to do y equals a is x minus h squared plus k. Again, the a value is just 1 on this one, so I don't even really need the a value, it's just a 1. All right, let's find the vertex. The vertex is negative b over 2a. This is my b, and my a is 1. So it's negative 6 over 2 times 1, which is positive 6 over 2, which is 3. For k, we'll take the 3, plug it into the equation. So 3 squared minus 6 times 3, which would be 9 minus 18, which is negative 9. Then put 3 in for h, so x minus 3. And then put minus 9 in for k, so minus 9. There's my final answer on that one. Again, you could always multiply this out and see if it actually gets back to here to make sure it worked. Okay, last one. Write this equation in vertex form. This one is in standard form because everything's multiplied out. There's no parentheses. You've got A, which is 1, B, which is 0, because there is no x term, and C, which is 5. However, this is actually already in vertex form because the vertex on this one would be 0, because there's no h in there with the x, 5. That's the vertex. So if there are no parentheses, it's just an x squared, then it's actually in both standard and vertex form already, and you don't have to do anything. So it's kind of nice. Okay, I think that's it.